Today I am going to explain the step-down converter. Here in a step, there are two types of converters. First is step-down converter and the step-up converter. In a step-down converter, output voltage is less than the input voltage, and in step-up converter, the output voltage is more than the input voltage. This is the circuit diagram of the step-down converter. Here the thyristor is in forward bias condition and one resistor is attached to it. When thyristor is on, supply voltage appears across the load, and when thyristor is off, the voltage across the load will be 0. Here the average voltage, put voltage calculated, the VDC is equal to T on upon V into T on upon T on plus T off, where the T on upon T is the duty cycle. In average output current, there the VDC upon R, where the IDC, which is the output current, average output current, is V upon R into D. When we calculate the output power, it is the multiplication of V0 into I0, which is the dV square upon R. And we are going to see the simulation of the buck converter. Here first we open the PSIM software, then take the new file. Here first I take the DC source for the supply. Then I take the MOSFET. Then take diode, which is in a forward bias condition. Then take one inductor and one resistor. Attach all the components with the connecting wire. Then I am going to connect the switch to the gate clock, because for on and off the switch we have needed a gate clock. Connect it with the wire. Then give the assign the values to all the source. Then the value of the gate is frequency is 5000 and the number of switching point is 2. And here the switching points are 0 to 180, which is the angle. Here for 50% duty cycle we have decided the 0 to 180 angle. Then give the value to inductance, which is the 500 microfarad. And for resistor the value is 12 ohm. Here then I connect the 1 voltage probe to it. Then run the simulation. First take V1 and see the simulation. Here the 50% duty cycle, but there is the ripples. When we saw the V2 duty cycle, this is in sine wave format, but there is the ripple cycles. So I am going to connect one capacitor across the resistor to reduce the ripples. Which is 200 microfarad. And the value of the inductor is also changed, which is 500 nanofarad. Then I look at the simulation and the waveforms of the V1 and V2, which is we give the 50% duty cycle, so 50% duty cycle, so these are in a similar manner. Then check the average output voltage, which is V1, which is 1.4500, and the average output RMS value of the V2, which is 5.27, and their time of the trace is 1.0. And here the 50% duty cycle, so look, here the one is similar to each other. Thank you.